Hey everybody, here is a solution to question 5a from oblique asymptotes. So I'm going to put on the screen what I think should be relatively given. I don't think we should have had any problems going through and dealing with intercepts. I'm hoping, and maybe this is tough to hear, vertical asymptotes and the limit check on those should have been pretty straightforward. I even put in one additional line in here to just show the substitution of 5/2 or negative 5/2, sorry. Those I think are okay. Where I think we probably hit our snag is dealing with the horizontal, and in particular in one spot. So let's take a peek. Now, what I put up in the top right corner, there is you going through and dividing by the largest power of x. I want to put that up there just so I can kind of come back and talk about it a little bit. But now, when you go through, I should say, to find your horizontal asymptotes, and you examine going forever left for that function. So 3 over x minus 1 over 2 plus 5 over x. Now we're going to imagine subbing in huge values for x, and in particular huge negatives, but huge values for x that are always getting bigger. So on the top, any fraction where the top is constant and the bottom gets bigger and bigger and bigger will approach 0. I then have my minus 1. On the denominator, I've got my 2. Same thing. Any fraction where the top is constant, the bottom gets bigger and bigger, I approach 0. Now, I need to deal with some signs. So let's take a look on top first. We're subbing in a huge negative number, so that's going to be a negative bit. I need to make sure that I have the sign on that bit because it's the first term in that expression on top. If those had been written in the other order, then you could have just written that as I am going to add on my negative bit, and you wouldn't have required the double sign. You could have just changed it and said subtract. I want to keep it in the order that it's written, though, so we can talk about some stuff. Okay, I'm going to slide that up. On the denominator, I now am subbing in a huge negative number, so I get a positive 5 divided by a big, means that is a negative bit. Okay, those bits are so close to 0, we're going to treat them like they're 0. So that whole fraction is going to simplify to negative 1/2. But now we need to remember it's not really zeros. So this is the snag that's going to come up. And I'm just going to slide this up a little bit to have a little more space. But it's because we have a negative asymptote. That's the issue. So I want to make sure that we're good with one of the differences that may pop up here. I'm going to go through and I'm going to examine nature of the curve. So on top, I'm going to have a negative bit, and then I'm going to subtract 1. That's going to make my top a bigger negative number. So I'm going to write that. That is a bigger negative. That actually makes my top bigger. Because my top's bigger, then I know that the overall value of the fraction increases. I have more pieces. My top is negative 1 point something. Okay, on the denominator, I'm going to subtract off a bit. That means my bottom is a little bit smaller, which means I'm dividing by a smaller value, which means I get a larger value. Now, here's the hiccup. When we examine those blue arrows, really all we're looking at is magnitude. I'm looking at the number. I'm not looking at the sign. So now what I have to do is I have to consider where is that bigger, both of those arrows mean bigger. Where is that bigger negative? And that tells me that I have to be below. Okay, if we have any problem with that, there's my set of axes. And if I quickly just put on a very crude, and I mean very crude for time, that value that my curve is a bigger negative than negative 1/2. That means bigger negatives are below that. So like -1. That means that my curve will always be below that asymptote. Okay, sometimes, just as I erase that, sometimes we can have a bit of a problem with kind of going back and thinking about larger versus smaller and thinking about our number line, when really what we're looking at is magnitude. Okay, let's jump over to the other side. So then I'm going to examine the limit as x approaches infinity for that same function. I'll slide in my f of x for time. So same thing. 3 over x is going to become 0 or approach 0. And on my denominator, 2 and my 5 over x is going to become 0 or approach 0. Now when I consider my signs, I'm summing in huge positive numbers. So that bit on top will always be a positive bit, and my bit on the bottom will always be a positive bit. Okay, now I need to examine that. So on top, that's going to approach -1, bottom 2. There's my so close to 0, treat them like they're 0. But now when I examine what's really happening on top, I always have a positive bit subtract 1. That makes my value on top smaller, right? Like it's going to be like a -0.9 something. So smaller on top. On the bottom, I'm now adding to the bottom. Well, adding to that bottom means I'm going to divide by a bigger number. That makes my overall value smaller. So the effect of both of those arrows tells me that I am going to have a smaller value. And now I need to tie in smaller negatives. And where would a smaller negative be compared to -1/2? That would be above. So that blue nature of the curve, that's going to probably be where we had our hiccup. Okay? Consider when we're addressing that value of the fraction, I have to be very conscious of when it's a positive asymptote or a negative asymptote, and making sure that I'm dealing with magnitude. Okay, I'm hoping that that helps you out. Hopefully we're able to put all that stuff together and form our sketch. Okay, best of luck with the rest of your practice.